Hello, Mr. Sutton here, bringing you the Algebra 2 3-2 Part 2 homework solutions on complex numbers. In this one we are adding, subtracting, and multiplying complex numbers with a little bit of electrical circuitry impedance thrown in for you honors folks. For this problem, we're just adding these two complex numbers together. Basically, we're just going to treat I like X and combine like terms. So getting rid of these parentheses, since we have invisible ones next to them, we can actually just lose both parentheses without changing anything else. And then combining like terms, we have 8 and 5, that adds up to 13. And negative I and 4i, we'll also group those together and add them. You don't really need to group them first, but just to be extra clear about what we're doing. So we have 13 then, and this will be plus 3i. For this one, we are subtracting these complex numbers. So the first parentheses I can lose for free. The next one I'm going to have to distribute a negative 1. So this will be a negative 3 plus 6i. And then optionally you can group the like terms together if you want. So we have a 7 and a minus 3 that are going to be combined, and a negative 6i and a positive 6i. Well, 7 minus 3 is 4. And the minus and the plus 6i just cancel out completely. So the real number 4 is the answer on this one. On this one, we just need to distribute and combine like terms. So we've got 7 minus 3 and then minus 4i. That negative 1 gets distributed to everything in there. And then that plus 6i is still hanging around. So we've got 7 minus 3, which is 4. Negative 4i and positive 6i adds up to positive 2i. And that's it. For this problem, we just need to distribute this 4i to both terms in here. So we've got 4i times negative 6, which is negative 24i. And then 4i times I is going to be a positive 4i squared. Since I squared is really negative 1, I can make this second term into just negative 4. And I'll write that first because I like my real numbers to be before the imaginary numbers. So negative 4 minus 24i is our final simplified answer. For this one, we are multiplying these complex numbers together. So we're going to start by just foiling this out, double distributing this out, and then we'll figure out what to do after that. So first, we have 9 times negative 4, that's negative 36. 9 times 7i is going to give us plus 63i. Negative 2i times negative 4 is a positive 8i. And then negative 2i times 7i is negative 14i squared. So a couple things I can do here at this point. These i's in the middle I can combine to get 71i, and that negative 36 is still there. And then since I squared is really negative 1, this becomes a positive 14 for that last term, which I now see that I can combine with this negative 36 back here to get me negative 22 plus 71i. On this problem, I'm multiplying these complex numbers together. Now, it just so happens that 5 plus 2i and 5 minus 2i are conjugates, which means I can use a little shortcut here. This is basically just the a plus b, a minus b shortcut of a squared minus b squared. So squaring the first thing, we've got 5 squared, which is 25. The second thing here, 2i, if I square that, I get 4i squared, and I'll be always subtracting that second squared term. Since I squared is really negative 1, this is really 25 plus 4, which adds up to 29. On this problem, they're asking me to square the complex number 3 minus 6i. Now there's a few ways you can go about this. You can write this parentheses twice and FOIL that out and go that way. Another way is you could use this a minus b quantity squared shortcut that we've seen. We actually used the reverse of this shortcut when we were factoring some things in the last lesson. So the basic idea here is we square the first thing, which is a 9, multiply the two things together and double them to get this middle 2ab term. So 3 times negative 6i is negative 18i. 2 times negative 18i gives us negative 36i. And then we square the last thing to get this b squared, so that would be a positive 36i squared. Now since I squared is really negative 1, this becomes a negative 36 at the tail end. 9 minus this 36 gives us a negative 27 out in front, and that negative 36i is just going to stay right where it is. For this problem, which is on the honors problem set, we are trying to find the impedance of this series circuit here. The trick to these is just knowing whether these numbers next to the ohms units are going to be reals or imaginary numbers, and whether they're going to be positive or negative if they're imaginary. So this first one, this is an inductor right here. This symbol tells us it's an inductor. And the number next to this is going to just be a positive imaginary number. So we have an impedance of 9I for that inductor right there. This 12 here is part of a resistor, and those come out as positive real numbers. So this is just a plus 12. And this is supposed to be like a double hash, but it's kind of hard to see. This is a capacitor, and those are always going to be negative imaginary numbers for that impedance. So this is a negative 7I is how we interpret that from this diagram. So we just have to combine like terms. This gives us just a 12 and a positive 2I, and that's in ohms. For this problem, we're trying to find the impedance of this series. So just going from left to right here, this squiggly thing on the left here, this is an inductor, and its impedance is always a positive imaginary number. So this 6 really represents 6I. And then we're going to add to that this resistor's impedance. That always is represented as a positive real number, so positive 4. And then finally we have this capacitor over here. That's always a negative imaginary number for representing it in this format. So this is really a negative 9I. And then if I add my imaginaries together, that's a negative 3I. So 4 minus 3I ohms is my impedance for the whole circuit.